Thank you, everyone. Now, first, before I begin, how many of you have used EFCore in the past? Okay, majority. And how about .NET? Just to see if we got... Okay, we got all of the hands. Bingo. All right, so what I'm going to talk about is some of the common mistakes that I found when working on client work, when working some internal projects, and occasionally also my own code, which was interesting experience going back and say, did I really wrote that? I am Jernej Kavka, but you can just call me JK. I am SSW Solution Architect. You can follow me in all of these socials. I'm one of the organizers for Brisbane Full Stack User Group, among of lots of AI user groups. I'm predominantly a .NET Core and EF Core developer, but I'm also a Microsoft AI MVP and ML.NET enthusiast. So first off, we are going to talk about a little bit about databases, ORMs, a little bit why I chose EF Core. Then I'm going to talk about my machine that was used for benchmarking, and that's important because the source code is available for you. So if you want to do benchmark and prove me wrong, you can do that. I challenge you. So you can try to make my examples better and show better examples. But the point of that is to also show you how you can do that yourself. So if you're wondering, okay, I have this query and this query, how can I make it test which one is better? Then we're going to move to 7 deadly sins. Those are the 7 ones that I'm like, yeah, you definitely should fix those. There's a lot more. There's like a mini best practices, just going through a couple of them. But the 7 deadly sins are the ones you definitely want to look into. All right. So many of you likely know there's a lot of databases. We have SQL Server, we have Cosmos DB, Postgres, MySQL, and lots more. Probably some of you can tell me 10 more databases. And we sometimes have problems choosing what database to pick. Now, these examples will be mostly centered to SQL Server. They're still applicable to a degree to PostgreSQL, to MySQL, essentially any kind of relational databases. The knowledge that you'll have will be applicable, and to a minor extent to NoSQL databases like Cosmos DB. And we also have various different ORMs. We have EF Core, we have Dapper, we have Martin, Cosmos DB SDK, and many, many more. We'll be focusing mostly on EF Core. Now, some of you may like Dapper, and Dapper is actually pretty nicely integrated into EF Core. You can set up EF Core, and then when you need Dapper, you can just reuse what you have from EF Core to use raw SQLs or some special features that are not yet in Entity Framework. But this is just to expose you that EF Core is not the only ORM around. So the reason why I'm focusing, and a lot of people, a lot of developers at SSW are focusing on EF Core, is because it gives us a great balance. So we can balance between great feature set, great flexibility, as well as performance. It allows us to choose what we want. It's really awesome for relational databases, and what's even more important as consultants is that we have a consistent way of doing migrations, database scaffolding, and other tooling that allows us to basically able to hand over the project to the client and just say, follow the EF Core instructions, and you'll be all good. Now, there's a few pains with EF Core as well. But most of these pains are quite easily solved. Most of the common issues that I have is hey, my query is running slow. And I look at the query, it's like, yeah, it took me only 5 seconds to realize why. So I'm going to show you how you can recognize some of the issues. And what also happens with that is your code can get simplified once you identify, what you shouldn't be doing in EF Core. And once you start benchmarking your code, I'm going to show you a little bit here as well. You can then be able to figure out, okay, this approach is better than that. And what sometimes happens with SQL Server and EF Core is that when you take one approach for one type of query and try to do the same thing for another query, you end up having different performance results. So sometimes you need to play around and see which one works best. And also, I'm going to show you some of the horrors that I have seen so you don't have to, hopefully, or be the author of those horrors. All right, so benchmark tools. So at the beginning, I'm going to use benchmark.net. That's going to be used for memory consumption and time duration. It's going to be used at the beginning just to show you the impact of some of the decisions that you may make at the beginning, especially if you're doing repository patterns wrongly. And Bombardier, which is going to be used for practically almost all of the sins, but not for the bonus ones, which is used to do like a local load testing. And it's local because we're not really interested specifically how well it's going to work in production. We're just interested which query is better. Usually that translates pretty well on productions, just the numbers are going to be different. And my testing environment, it's going to be .NET 7 with EF Core 7. That used to be beefy machine, it kind of still is. Ryzen 9 5900X, 12 cores, 24 threads. So if you're getting much better results or much worse results, that could be the reason. And 32 gigabytes of RAM. I'm saying that if you run it yourself, you can then see whether you're getting vastly different results because of your hardware or something else. Also, some of the examples haven't been, the benchmarks haven't been updated yet for .NET 7. So you might get better results just because of that. Lastly, test data is from SQLskill.com. It's the sales DB. I took this database because we have 7 million cells. And the reason why I picked this one specifically is it often happens that you start a project, you built on it for 6 months, you have test data, it survives staging, it goes to production, and then 6 months later, the client calls and says, everything is slow, everything is on fire. And this one kind of hopefully demonstrates why things may go bad after 6 months. All right, finally, deadly sins. All right, so let's get from easy to hard. So first one is IQueryable to IEnumerable. This one is horrifying, and I'll show you why just in a bit. AsNoTracking. Then we have explicit joins. We'll have get only the columns you need, which should be obvious for a lot of people who have worked with SQL databases, but not everyone thinks about it when they use Entity Framework. Pagination. There's a lot of developers that I have worked with. They just downloaded everything and then done in-memory pagination on the client. And I'm like, of course it works slowly on the client and on the backend because you're downloading everything. Non-cancellable queries. This is really good if you want to also protect yourself from denial of service attacks. And inefficient updates and deletes, which is a very new feature in EF7. All right, so one question you'd never want to ask. How bad can it be? Usually the answer is what you don't want to hear. So first off, IQueryable versus IEnumerable. So what that means is, see this example here? We have salesdb context.sales, and then we do toList. Now, how many of you know what happens when you do this? We have a few hands. Okay, let me explain. So what happens is you take the entire table of sales, you download it into memory, you do mapping, you do lots of different things. You use up a lot of memory and a lot of CPU, and then you count them, and then you throw everything away. So, and you never even look at the data, you just count how many rows there are. As you might imagine, that is not particularly efficient. But you know what? We have this example. So this, IEnumerable cells. And we also have this example. We have an IEnumerable cells here as well. So basically, what we're doing is the sales property here is IQueryable. And what well, technically it's DB set, but it's casted into IQueryable based on the usage. But what happens in all of these cases is it gets casted to IEnumerable. And they're all the same. So when you see a repository that returns IEnumerable, run. Because you are potentially downloading the entire database. And this is where we had to refactor a lot of repositories to return IQueryable, just so that they don't download the entire database for every single request they do. Now, why does this happen? Well, here I have a diagram. So we start with HTTP request. We have this salesdb context.sales, which is IQueryable, but we cast it to IEnumerable. So what happens next is that EF-core says, okay, you want to convert it to IEnumerable. I'll just evaluate it, everything up to that point, and then convert that into SQL statement, which then goes into the database. So basically what it does is select stuff from sales. And then it goes to SQL Server downloads the entire database, it throws back to EF-core. The EF-core has to now pass all of that. Now, sales have 7 million records. So that means that it needs to pass through 7 million records. And then it adds tracking, so it can change, so it can track changes throughout all of the 7 million records. And then at the end, it counts them and throws everything away to garbage collector, and garbage collector hates you now. So what should you do? Well, it's very simple. First off, don't use IEnumerable, use IQueryable when you're in situations like this. Jason Taylor, actually, for clean architecture, you mentioned a different approach. There's different libraries where you can actually encapsulate IQueryable. It escaped my mind the name of it. But you can then write rules that, sorry? No, the one that you can write rules for it. Predicate builder then, yeah. Where you can you can abstract IQueryable and then you don't use the IQueryable directly. But in, okay. Anyways, not important right now. Do not use IEnumerable. Because when we do .count, what happens is now that we're using .count directly on IQueryable, EF-core is like, oh, wait, you just want to count rows, right? So it then does select count stuff from sales, which then gives you a single integer back. And .NET is like, that's easy. I'll take this integer and get back the code. So what I'm saying is IQueryable plus EF-core is in no way similar to IEnumerable. So they look the same, they seem to work the same, but they're very, very different. You can think of that IEnumerable is almost always in-memory processing. Whereas IQueryable, you don't actually know exactly what is the source. Now, if you're using EF Core, it's probably going to be SQL Server. But it could be something else. It could be CRM Dynamics. It could be some GraphQL. You don't know. So that's the major difference. But you'll ask, what's the impact of it? Well, let's just say that it's 1 million times more memory. That probably would be a good deterrent to not use that. And it's 64 times slower than, just counting in the database. And it's full 3.5 seconds faster. Now, this is just this particular example. I have seen some examples that basically maxed out the RAM and failed. And another thing that is really important, like what you can see here, I'm using Bombardier. And what you can see, I use some parameters. I think this is 5 threads. I run it for 60 seconds, and I have timeout for 60 seconds. And I put here the URL. So I'm saying, just hammer this URL as fast as you can with 5 threads and tell me what's going to happen. So what happened here is that on average, about 30 seconds took for each individual request. Basically, that means that it finished about 10 requests in 60 seconds, which is not really a lot. But if we look at the one that we used counting in the database, it finished in 128 milliseconds. So that is 260 times faster when you're trying to do load balancing against that one web request. So you remember previously it was 64 times faster. It turns out when you put some load, the difference becomes larger, which is why sometimes it's more important to test how your code performs on load rather than a single run. Now, the next one is AsNoTracking. And what AsNoTracking gives you is it excludes the change tracking on entities. What that in a nutshell means, it lessens the memory consumption, it lessens your CPU consumption, but what you lose is the tracking changes. So for instance here, I have AsNoTracking changes. So when these entities are returned back from this method, when you do any modification to it, EF Core will be non-divisor. It will not know that any changes were made to those entities. Now, why would you want to do that? Well, if you look at the diagram again, here we have the EF Core generates a query. It sends a SQL query to the SQL Server. SQL Server responds back with some data. EF Core passes the data, maps the data, and what then happens is it adds tracking properties to it, and then it continues back to your code. So basically, for every row and every column, you have additional properties that you don't quite see without some extra code. But what happens with AsNoTracking is that part is skipped. Now you might ask yourself, well, that doesn't seem to be a big impact, right? Well, unless you would like to have lots more available memory. You can get sometimes even up to, I think the largest number was 10 times less memory consumption. And it's also depending on the number of entities you get back and the complexity of those entities. Generally speaking, you get like twice the speed. Sometimes, I think the largest number was 12 times faster. And that stacks up when you're running this a lot of times. And also when we do load testing, you can see that we're getting 4 times better performance. Not quite as good as the single run where it was 5 times faster, but still pretty big difference by just adding one line. So if you're not tracking any changes, if you don't need to save changes to the database, always use AsNoTracking. Now, if you do .select and you manually specify what properties are interested in, it will indirectly add AsNoTracking. So all of the things inside of it will be untracked. Another thing that I found very interesting is explicit includes. So how many of you used .include directly? We have a couple of hands. I hope that I'll convince you not to do that. So the reason why you don't want to do that is, imagine that you have a .select statement where you specify what you want from the database. But if you remove all of the things that you no longer need from, say, from the customer tables, but you leave the include in, it will still join the table, even though you don't use it. And that actually gives you real performance impact. So what you want to do is, instead of using .include, you want to do a select statement and specify them directly in the select statement. Because what happens in EF Core is it will implicitly include everything that you include in the select statement. That also means is if I remove these two lines, it will no longer join to the customer table. It's gone. And I don't have to worry about that. But if I do manual includes, you might end up having, if you over remove includes, you might end up with null values and null reference exceptions, or you might end up with too many includes just to be on the safe side. One of the most common problems that I have seen is somebody in repository made a query that includes everything under the sun, and then returned that IQueryable, and you're like, I just want this small slice of data, but because they used .include, it actually dragged the entire database with it, even though we didn't even use that data. Now, the impact of that can be quite significant. In this particular case, we have about 2.5 times slower with doing explicit includes, where we had one include that is no longer used. This is, just an include that we don't use it anymore. So it's just useless. And we can have 2.5 times slower code. So this is why you don't want to use explicit joins. Now, when we talk about pagination earlier, I have seen a lot of inexperienced developers not using pagination. And what happened is, as the data grows, the UI is becoming slower and slower and slower. And they use in-memory pagination on the client to make filter everything. And one of the main reasons why they were doing this is because they didn't know how to count before filtering. So what they did is they done here get all filtered data to link. So this is actually not filtered. It just gets all of the data that it was supposed to be for that page. So not page, that search. They count it, and then later on they filter it in memory. So sometimes they do it in the browser, sometimes they do it in the backend. But what they usually end up doing is they doing query, the entire query without the pagination. Now, how you can solve this is you can think of that you can run the IQueryable multiple times and you can compound different queries afterwards as well. So here we have a query. We done the select, we done the where clause, we set it as not tracking. Now here we wouldn't need to do as not tracking, but I still like to add it to be explicit that we don't want to change anything. Over here, what we do is we're asking SQL Server, hey, here I have query, can you count them? And this is fairly quick. It's a lot faster than getting the entire list. And now I am actually expanding the existing query to do the filtering. So now I can run await query to list async, and it will give me only the slice I'm requesting. So now I'm no longer requesting to get the actual data, the whole lot. Like imagine you have 7 million sales. You would need to download all the 7 million sales, take 10 of them, and then drop the rest of them. That would be a massive loss. Here, what I'm saying is, hey, count those 7 million sales, give me the number, how many there are, and then I just want to have 10 of them, 10 actual data. Now, you can imagine that this can be really, really slow. Now, luckily, my machine is pretty fast, and I think I actually had to limit how many. I think I actually had to do like take only 1,000 of them or something like that, because my machine wasn't able to load test with all 7 million sales. It actually timed out. So the worst case scenario is actually not worst case scenario because the worst case scenario didn't work. But the best case scenario actually works against 7 million. And it's super fast. And another thing that is very important when you're doing development, or especially on large scales, is non-cancellable queries. Now, did anyone use cancellation tokens in .NET? Awesome. Do you actually pass those cancellation tokens to the appropriate methods? Okay, half of them raised for both. So you might know what's coming. But let's say that we don't use cancellation tokens. What would happen? So for those who don't know what cancellation tokens are, when you make a web request, you can actually add a parameter saying cancellation token. And what you can do is you can then pass down that cancellation token to asynchronous methods. And what that happens is when we have an HTTP request and say that we have an EF core query sent to SQL Server, that is an asynchronous operation, that thing can process, say, a minute on SQL Server. Let's say that we have a very, very long query. And what might happen is that your user decided, actually, I don't want to wait a minute. I'll cancel the request. And the cancellation token is getting canceled. But if you do not pass the cancellation token to the EF core, it will just keep on going. And because it doesn't know it's been canceled, it's actually just going to process further. Now, the only difference that will happen is when you respond back in the API controller, it will look at, oh, wait, the request was canceled. I'll just disregard everything you just gave me. So basically now you have wasted a lot of time on SQL Server just for .NET to say, oh, well, we don't need it anymore. But what you can do instead, so here we have cancellation token, and we add some cancellation token underneath in the toList async, or first of default async. And what happens is we're getting the same request as before. Now, when we have a cancel request, that cancellation token goes all the way to the SQL Server. And what happens is the processing stops, not just on the .NET side, but also on SQL Server side. So what that means, if somebody is basically just trying to DDoS you by just pinging your website and quickly canceling and then pinging again. This is going to try to minimize the amount of workload that you'll have on your .NET application and on your SQL Server. If you don't do that, every single request will run to completion. So people would not even need to have a lot of resources to overwhelm your system. And this, as you may imagine, can have big impact on your performance. So basically what I have done here is I had a long-running operation. I put the timeout to be shorter. So I think that was 1 second's timeout. And what you can see is the original method, the original without cancellation, tried to finish it to completion. The second one, they still try to run it to a certain point, but it canceled and finished computation much early on. This timing is mostly because we are overwhelming the system more than it actually runs for more than 1 second. Also, the responsiveness is much better. So here I intentionally tried to overwhelm the system. So if anyone tries to run this, yeah, just make sure that your cooling on your machine is great. Because the first one is going to, let's just say, your machine is going to have a good time or bad time. As is written here, it took 40 seconds after the run for the machine to respond again. All right, so the last one, the deadly sin, is how we update all of our entities. Now, how many of you have heard about the new feature that you can update and delete in EF7 without actually getting the entities first? We have just a few hands. Okay. So what happened before EF7 is if you want to update an entity, something you want to update, you first need to fetch it from the database and it needs to be tracking. Then you need to modify it and then you need to save changes. Now, what that means is that you need to have at least one select statement and one update statement. And same thing is for deletion. So even though you have the ID of the entity that you want to delete, you kind of need to get it from the database first, and then you have to delete it. Now, there's tricks of how to do it without getting the entity from the database, but we have now a feature that actually solves this problem. So here is how we would do it in the old ways. So we have here a query. We get the list of the employees. In this case, I just want to swap the first name with the last name, just because I can. And I do a full loop, and then I save changes. What's important here is I'm doing a select statement over here, and I'm gathering all of the data, and I'm not interested in all of the data. I'm just interested in first and last name. But because it has to be tracking, I need to get all of the columns. And here you can see there's a couple of updates statements. There were about 26 update statements. So each entity is being updated separately. Now, the new feature allows us to just say, hey, I have this query over here. I can even add a tag with, which basically adds a comment in the SQL query. And then I say, I want to update. Make the first name a property as last name, and make the last name as first name, and save changes. Isn't that awesome? I don't need to take any of the data from the database. I can just say, hey, this is what I want to update. And this is the SQL query. Very nice and simple. We just have an update, last name, first name, we set it to be reversed, and that's it. Done. And the difference in performance here, I only done against, I think it was 23 records. I missed that I have actually a custom table, and then I didn't have time to update all of the slides, which had 3,000 customers would have a much nicer numbers. In this particular case, it's 3 times faster. And we're only talking about 23 customers. If we would have 3,000 customers, the difference could be in hundreds of thousands. It can get, in some of the client work that we actually had to write raw SQL to update entities through raw SQL, because that was sometimes in the range of tens of thousands times faster than trying to do the methods where you get all of the data from the database first and then update them. Especially if you do logs and you just need to update one variable in the one column in the logs. All right, so I've gone through the most important sins. Now I'm just going to go real quick through a couple of mini best practices, other horrifying things that I have seen and what you should definitely avoid. Yeah, don't do that. When you're trying to get any, don't try to download the entire table and then just say, if they're more than 0, then true. That's not how any works. You should just say .any. Please, I have seen this code more times than I dare to say. And here we have get sales. And what they try to do here is basically they want to add multiple filters here. And what they do is they're just getting everything from the database, and then they want to in memory do additional filtering that is sometimes optional. Don't do that. IQueryable allows you to composite way clauses. So what I can say is I have the query over there, and okay, sale ID is not null, so I'll attach this way clause as an additional condition to the query, and then at the end I'm going to do toList. So do not download the entire database and filter it in memory. Now, if you want to work on scalability, use DB context pool when you register EF core instead of DB context. What this allows you is, did anyone hear about HTTP client pool? We have a few hands. So what that means for DB context pool as well as HTTP client pool is that it tries to recycle the connection. It tries to recycle the expensive objects so that you don't waste on CPU. You spend a little bit more on memory, but it's negligible. And most importantly, you don't waste resources on connections. If you need to do a lot of different requests toward database in different HTTP requests, you may run out of connections, especially on HTTP client when you do things in parallel. And the pools allows you to avoid that. And it makes also your application more resistive against high load and denial of service attacks. Now, I have shown the tag width before, and the reason why I want you to use on every single query that you can, now you can do it also on update and delete, which before EF7 was impossible, because when you go through SQL Profiler, you can see on top of here the same comment that we have a tag width. Now, if you end up with an application that has a lot of similar queries, this will allow you to identify from where you called it. And sometimes what happens with EF, especially with older versions, but you can optionally make that for newest one as well, it splits the queries. The EF7, most of the queries are not split, but sometimes they can be split. You can say that you want to be splitted. And all of these splitted queries will have the same comment. So if that happens, you'll be able to then identify, okay, they're two different SQL statements, but they're all coming from the same link statement. Then bulk processing. In .NET 6, we got a link statement called chunk. What that means is it gives you arrays in size of 10 in this particular case. And why you want to do that is if you want to fetch data, like here I want to get all of the products with these IDs. SQL Server can process, I might be mistaken, but 100, up to 100 IDs somewhat efficiently. It may depend on, how powerful your SQL Server is. The more powerful it is, the more IDs can efficiently process. Say if you go 200, the query becomes less efficient. And chunking allows you to just say, we know that based on our configuration of SQL Server, it can handle well 10 IDs at a time. And this can end up having a much significantly faster code, even though we end up having the same amount of data returned, just, in chunks. And one of the favorite things that I like to do is combining lots of different things to actually make things more efficient. So here I have a for loop, and this is used something, we had a project where we had to synchronize CRM. It was really old code, and it took like 20 minutes to synchronize the data, and they asked us, hey, can you make this faster? But this is .NET Framework. So that's, if you see horrible code, it's because it's really, really old. And what they've done here is, for each loop, they say, hey, if the cut ID wasn't available in the CRM data, so it's not stored over there, check the database, our database, if you can find it. Now, this could be a problem if this happens 3,000 times. And that's what happened here. So this is a little bit more complex, and if you want, I can share the code with you later. But what I have done is basically, I have built a generic method service where I can actually say, hey, I want to lazy load the data, but I want to go through all of the IDs and I want to load them later. So here I have a method saying, hey, when I get the data, for this entity, set this property to be this. So it's kind of a callback. Once I get the data, this is what I want to do. And instead of fetching the data from the database, what I say is just, hey, just add this key, this GUID, to the list. And this is the entity that needs to be updated once I have the data available. And the last part is, hey, once I have all of the data, resolve it. Just try to fetch all of the missing data and set it up with this callback up there. Now, the cool thing here is I have here null, but this can be dictionary. And for a few things, we do have dictionaries. So if I already know the mapping, I don't even include it in the list to get the data. I just set it up immediately. That's why this is set up here right away. Now, I'm not going to go into details. If you're interested, I can show you afterwards. But what I'm doing here is several different tactics. One is I have the list of all the keys I'm interested. So what I can do is I can remove any duplicates, because now I have a full list of what I'm interested. Then I can say, oh, wait, there could be thousands of them, right? I'll just batch them so I don't overwhelm the SQL Server. And once I go through all of this, I can then say, I'll basically update the properties that I need to retroactively. But if I have a dictionary, I'll store the data for future use. So if I have multiple methods where we have synchronization and we try to map things around, I don't need to get the same data over and over and over. And this got us from 20 minutes to 3 minutes, and we haven't even started doing EF core optimizations yet. So this is how much you can save up time just by smartly shuffle around of how you get your data. And this is not just EF core specific. This is what you can use for any kind of framework. This is just how you fetch the data. But this is a specific implementation for EF core. And funnily enough, this is actually Entity Framework 6. So you can copy literally this code, put it in EF7, and it will just work. All right, key takeaways. Please do not use IEnumerable. Please. If you have IQueryable, unless you have a system that allows you to encapsulate IQueryable, or you understand what it means to cast from IQueryable to IEnumerable, do not cast IEnumerable just because it looks fancier and more generic. Understand what happens when you do that. AsNoTracking can give you a very easy way of getting massive performance impact. And most of the queries that you'll do, AsNoTracking is the way to go. Just make sure that the entity isn't something that needs to be updated. And sometimes you can write much simpler code and end up with much better performance. Here we have some of the resources. We have rules to better entity framework. We have the GitHub where you can get all of the codes and you can do benchmark yourself. Just wait for a second for the pictures. So you can also find the presentation here on this link. I'll send the updated version tonight. Thank you.
Questions?
Yes?
.NET comes with a different analysis. Do they have a powerful analysis specific for the PS4?
So the question is, .NET has different analyzers. Does EF Core come with specific analyzers? And the answer is yes. And some of the things that you'll see that you've seen here, you will get squigglies, but for a lot of them, no, because they're technically correct. It's just semantically they are grossly incorrect. Any other questions? All right, thank you.